everyone, my name is Koo Jin-ting and I'm from Group B. Let's find out the other members in this group.
My name is Muhammad Firdaus bin Abdul Qasim.
Hello, my name is Nur Dahlia Adila Minti Mahadi.
Hello everyone.
Before step into the world of solar energy, let's get to know what is solar photovoltaic, solar PV, and how it works.
A photovoltaic or PV system is used to convert the solar or light energy into electrical energy. The basic component of the PV system is known as the solar cell. How does the solar cell work? The generation of electricity on exposure to sunlight is known as the photovoltaic effect. This principle is used by solar cells to produce electricity. The solar cells are made up of semiconductors, mainly silicon, and comprises 3 layers. The top layer, called the N-type layer, is comparatively thin and contains high concentration of electrons. The bottom layer, called the P-type layer, contains high concentration of holes. When the P-type and the N-type semiconductor is joined, it forms a p-n junction. On forming a p-n junction, the electrons of the N-type material try to reach the p region, creating a negatively charged layer. Similarly, the holes of the p-type material try to reach the N region, creating a positively charged layer. This region, between the 2 layers, is known as the depletion region of the semiconductor. Sunlight penetrates the top thin layer easily to reach the depletion region. Due to the deficiency of charge in the depletion region, it contains neutral atoms. These neutral atoms are broken when the photons from the sunlight strike the depletion layer. This knocks the electrons from the neutral atoms, leaving behind the holes and producing free charge carriers. Then, the electrons move towards the N-type layer and the holes move towards the P-type layer due to the electric field present in the depletion region. On connecting an electronic circuit, the electrons flow through it, generating electricity to electrical devices like bulb, fan, etc.
This is the timeline of policy for the solar voltaic in Malaysia. In 2005, implementation of MBIPV, which is Malaysian Building Integrated Photovoltaic Project. In 2010, the implementation of FIT, which is FIT in tariff. In 2016, the commencement of NEM 1.0 instead of NEM, which is Net Energy Metering. In 2019, NEM 2.0, and lastly, from 2021 until 2023, NEM 3.0. Implementation of MIBPV. The MIPV project specially focus on the market development of BIPV technology and building national capacity in 3 major areas. First of all, the policy and education, technical skills and market implementation, and lastly, the technology development support. Next, implementation of FIT. FIT is a policy scheme that allows RE producer to be paid as a rate of tariff for each unit of electricity fed into the grid, and this is generally obligates the power companies to purchase all the electricity from eligible procedure in their service. Next, the important highlight for the latest policy Net Energy Metering 3.0. A mechanism where an eligible consumer install the PV solar system primarily for own use and excess energy to be exported to the grid. This NEM 3.0 was introduced by the Energy and Natural Resources Ministry via a press statement by KETSA on 29/2020. NEM 3.0 is introduced because of the overwhelming response from the PV industry and in an effort to increase the usage of solar energy in Malaysia. This is 3 new initiatives or categories will complement the NEM 3.0. First of all, NEM Rakyat Program, the quota allocation is 150 megawatt. Next, the new government program, which is government, ministry and entities, the quota collection is 100 megawatt. And lastly, NOVA program. NOVA instance of net offset virtual aggregation, which is the quota allocation is 800 megawatt. Next, trend and development of the solar sector in Malaysia. There is two development, the current development of the solar sector in Malaysia. First of all, Selangor Solar Vest Floating Solar PV Park. The project is developed by owned by Solar Vest Holding. It started in October 2020. This project is spread over an area of 53 hectares. In this project, it will generate 16,640 megawatt per hour electricity in supply and clean energy to the power for 5,800 households. Next project is TNB Kedah Solar PV Park in Malaysia. The project is owned by Edra Power Holdings Berhad. The company has stake of 100%. The project is begin in 2019. This project is spread over area of 2060 area. This is the trend of the solar sector in Malaysia. We can see from the graph, it continuously increasing from 2012 to the 2021, which is the latest one. The source is from International Renewable Energy Agency, which is ARENA.
As we dive into the potential of solar PV, we cannot ignore the challenges that come with this brilliant source of power. The same thing happens to other kinds of renewable energy. So, it is important to figure out what is the challenges behind solar PV in Malaysia. The discussion today will cover a few challenges from different aspects, which are government, public, environmental, technology, and energy efficiency challenges. Firstly, the government challenges can be narrowed down to the lack of consistent and clear policies, the high upfront costs, and lastly, limited available space for large-scale solar installation in Malaysia. The strategies done by the government to solve these challenges including to provide supportive policies that encourage solar PV adoption, promote subsidies and tax incentives to make solar PV more financially accessible to everyone, and finally, explore innovation solutions like floating solar installations on bodies of water. Shifting gears to the public perspective, we encounter limited awareness about the potential of solar energy, limited competition in solar market, and lack of a well-established supplier chain for solar components. Also, there is a lack of skilled workforce for the design, installation, and maintenance of solar PV system. How about the solution? Public awareness campaign, market fairness promotion, as well as a robust supplier chain via investment in local manufacturing. Also, don't forget to establish training programs with educational institutions to build a skilled workforce for the solar industry. Now, let's tackle environment challenges. The challenges include pollution concerns arise from solar PV manufacturing processes and e-waste from unusable solar panels. In this case, environmentally friendly manufacturing practice could be researched as well as promoting recycling programs for end-of-life solar panels. Then, another challenge is unpredictable weather patterns which affecting solar energy generation. To overcome this intermittence, a forecasting system could be developed to predict solar energy generation based on weather patterns. Or we also can combine solar energy with other renewable sources for a more balanced and reliable energy supply. Apart from that, for technology challenges, we cannot deny that integrating solar PV system into the existing power grid is not easy, and there is a need for infrastructure upgrades in Malaysia. Due to this reason, experts are much needed to address grid integration issues and upgrade infrastructure to accommodate solar energy fluctuations. Besides, in Malaysia, there is a limited research and development in solar technology to improve its efficiency and cost effectiveness. So, the government can consider allocating funding for R&D in solar technology and foster collaboration between industry, academia, and research institutions to drive innovation and efficiency improvements in solar PV system. As future engineers, we are not just spectators. We also hope that we can contribute some findings related to the solar PV field. Lastly, for the energy efficiency challenges, Let's see how the expert think.
Ultimately, the renewable energy that we want would be mainly from solar. That's the most promising that we have, a source of renewable energy that we have in Malaysia right now. But even then, it's intermittent. That's always the challenge with solar energy. And with the huge subsidies that has kept the tariff very low, it means that new technologies like battery storage and whatnot are not viable yet in Malaysia. That's why that shift is very crucial for Malaysia to adopt more renewables.
Although, to be honest, if we look at different renewable energy and we adopt the so-called capacity factor as a measurement for the efficiency of different energy forms, solar is indeed the less efficient in terms of the percentage of time in which the system can produce energy at maximum capacity. It is less than 25% of the time. So we have a problem of affordability of the system in itself, but then we have also a problem of efficiency of the system. I think that research and development needs to move in the direction of the reconciliation of these two aspects, because if a system is not financially sustainable, then in the long run cannot be adopted in a massive scale.
That's all from me. Let's move to the next section.
In this chapter, I would like to talk about the advantages and disadvantages of solar PV. There are many advantages of solar PV, but I would like to take a few of the advantages, which is solar PV can reduce the cost of energy bills, secondly, resources availability, environmental friendly, low maintenance costs, and lastly, long lifespan. For reduce the cost of energy bills, once installed, solar PV system can lead to significant cost savings on electricity bills as they generate free electricity from sunlight. For the resources availability, solar energy is abundant and available throughout the day, while other renewable energy such as wind energy that is dependent on the wind speeds, which can vary. This makes wind energy available less predictable than solar energy. For the environmentally friendly, energy that is produced by solar panels is clean, renewable and has zero emission. Solar energy does not contribute to greenhouse gases or fossil fuels unlike other oils and coals. For the low maintenance costs, advancement in solar technology make maintenance easier and more efficient. Low maintenance costs. Advancement in solar technology make maintenance easier and more efficient. Solar PV have relatively low operating maintenance costs with no fuel expense and minimal maintenance requirements. And lastly, long lifespan, often exceeding up to 25 years as they continue to generate electricity over an extended period. The cumulative savings on energy bills can be substantial. For the disadvantage of solar PV, which is high upfront costs, low energy conversion rate, intermittency and weather dependency, manufacturing and disposal impact, and lastly, space requirement. For the high upfront costs, solar PV systems have a substantial initial investment, but ongoing incentive and decreasing cost aims to make them more economically viable. For the low energy conversion rates, solar panels have a variable energy conversion rates, prompting ongoing research, improve efficiency and to overall energy yield. Thirdly is intermittency and weather dependency. Solar energy production is affected by weather conditions, and addressing intermittency involves integrating energy storage solutions and smart grid technologies. For the manufacturing and disposal impact, they are not eco-friendly and to mass manufacture. Energy-intensive manufacturing and environment concern during disposal contribute to overall environmental impact. For the space requirement, available space is a big factor of solar panel installation. Large land requirement for solar installation may pose challenge, especially in densely populated areas.
Hello everyone. Today, as a part of this presentation, I would like to discuss about the statistics and facts about the solar PV growth in Malaysia. The solar photovoltaic PV landscape in Malaysia has undergone significant transformation in recent years, reflecting the nation's commitment to adopting sustainable and renewable energy resources. Peninsular Malaysia offers high-quality resources as already reached grid parity with gas. Currently, distributed solar energy accounts for the majority of installed solar capacity. In 2020s, utility-scale solar is already cheaper than gas, while in late 2020s, solar plus storage reached grid parity with gas. Since that, the installed capacity in Malaysian solar sector have been increased rapidly. Next, we're going to discuss about that Malaysia has grown its solar capacity through solar auctions. To date, it has held 4 held rounds of auctions, awarding a total of 2.3 gigawatt of solar capacity in Peninsular Malaysia. 825 megawatt capacity is already operational, while the rest is currently being developed. Kedah, Terengganu, Perak and Pahang regions appear to experience higher solar penetration of more than 200 megawatt, followed by Negeri Sembilan region. LSS auction rounds 1 to 3 welcome foreign investment by allowing consortium with local players with 51% local stakeholder ownership, while the LSS round 4 was only open to either 100% local owned companies or companies listed on Bursa Malaysia with at least 75% local shareholding ownership. Next, we're going to talk about the installed capacity of solar energy has expanded from 205 megawatt in 2014 to 2165 megawatt in 2023, showing that favorable government policies and auction in different end user sector have led to a large growth in the solar industry. For example, Malaysia's National Energy Policy (NEP) 2022 to 2040 was announced in 2022 with the goal of having 4% of solar energy in the nation of fuel mix by 2040. The NEP also stressed the need to enhance and unlock the potential of domestic solar resources by launching programs like a long-term pipeline of large-scale solar LSS projects, rewarding a dual-use agrivoltaic solar farms, expanding net energy metering (NEME), and improving capital access for distributed solar. Malaysia generates 3.1 terawatt of energy from renewable sources in 2021, an increase of about 11% over about the previous year. The Sustainable Energy Development Authority (SEDA) also introduced NEME 3.0. By 2030, 4,000 of megawatt of renewable energy will be produced, according to Malaysia's renewable energy policy. So here we come to the last part of this presentation, solar energy market in Malaysia. The Malaysian solar energy market is semi-fragmented. The key players in the market include J Solar Technology, TNB Engineering Corporation, Solar West Holding, Canadian Solar, and Plus Energy Holding Sdn, and among others. January 2023, Advancion Holding Sdn announced its strategy to invest USD 5.13 million to fund the development of a solar photovoltaic PV project under the Large-Scale Solar for LSS4 program under the Mentari program. In October 2022, the Government of Malaysia invited application of 600 megawatt under the Corporate Green Power Program (CGPP) through the Virtual Power Purchase Agreement (VPPA) mechanism. It will attract all the solar energy developers who wish to sell electricity to corporate clients based on mutually agreed pricing. That's all from me. Thank you.